Real-world applications of Cartesian products. So far, we've been building up our understanding of sets, groups of objects, and something called the Cartesian product, which is a way of combining elements from those sets to create ordered pairs. Now, on this slide, we're going to shift gears a little bit. We're going to move beyond just the abstract mathematical definition and start looking at where this concept actually shows up in the real world. Think of it like this: we've learned the rules of a game, and now we're going to see how that game is played in different situations. We'll explore practical examples to help you see how Cartesian products aren't just a theoretical idea, but a useful tool. By understanding these real-world applications, you'll not only strengthen your understanding of what a Cartesian product is, but also appreciate why it's a valuable concept in mathematics. It's about connecting the math we learn to the world around us, and that's what makes it truly powerful. In the following slides, we'll start with a very fundamental example: how Cartesian products relate to coordinates on a grid, and then move on to more relatable scenarios like creating combinations of outfits or meal choices. Mapping coordinates on a grid. So let's move on to a really important application of Cartesian products. As we discussed in the previous slides, Cartesian products are about combining elements from different sets. Now, we're going to see how this idea shows up in something you've probably already encountered: the coordinate plane. This slide title is Mapping Coordinates on a Grid, and that's exactly what we'll be doing. The coordinate plane is built using two perpendicular lines. Think of them like the edges of a cross. We call the horizontal line the x-axis and the vertical line the y-axis. Now, every point on this plane needs a unique address, right? That's where ordered pairs come in. Each point is identified by an ordered pair, written as x, y. The x value tells you how far to move horizontally from the origin. That's where the x and y axes cross. And the y value tells you how far to move vertically. So x represents the horizontal coordinate and y represents the vertical coordinate. Remember, the order matters. X, y is not the same as yx. Now let's connect this back to Cartesian products. Imagine we have a set, let's call it A, that contains all the possible x-coordinates we're interested in, and we have another set, B, containing all the possible y-coordinates. The Cartesian product of A and B, written as a cross B, gives us all the possible combinations of an x-coordinate from set A and a y-coordinate from set B, and each of those combinations, each of those ordered pairs, represents a point on our coordinate plane. Let's look at an example. Suppose our set A, representing the possible x-coordinates, is 1, 2, 3. And let's say our set B, representing the possible y-coordinates, is a B. If we take the Cartesian product of A and B, across B, we get the following set of ordered pairs: 1A, 1B, 2A, 2B, 3A, and 3B. Each of these ordered pairs represents a point on a grid. For instance, if we think of 1 as 1 unit along the x-axis and A as 1 unit along the y-axis, then the ordered pair, 1A, represents the point that is 1 unit to the right and 1 unit up from the origin. This is a fundamental concept, and it will become even clearer as we move on to the next slides, where we'll see how Cartesian products apply to even more real-world scenarios. Creating combinations. So let's move on to looking at some real-world applications of Cartesian products. As we discussed on the previous slide, we've learned what Cartesian products are, how to create those ordered pairs from sets. Now, we're going to see where this actually comes up in everyday life. This will really help solidify your understanding. This slide focuses on how Cartesian products help us deal with combinations. Think about it. A lot of the time, we need to figure out all the possible ways to combine things. A great example is choosing an outfit. You have different shirts, and you have different pants, and each outfit is just a combination of one shirt and one pair of pants. Let's formalize that. We can represent our shirts as a set, which we're calling S. This set contains red shirt and blue shirt, so S equals red shirt, blue shirt. Similarly, let's represent our pants as a set P, which contains jeans and shorts. So P equals jeans, shorts. Now, to find all the possible outfits, we need to find the Cartesian product of S and P, written as S cross P, remember. The Cartesian product gives us all the possible ordered pairs we can make by taking one element from the first set and one element from the second set. In this case, S cross P gives us the following: red shirt, jeans, red shirt, shorts, blue shirt, jeans, and blue shirt, shorts. Notice how each of these is an ordered pair, a shirt and a pair of pants. Each of these ordered pairs represents a unique outfit. For example, the ordered pair, red shirt, jeans, simply means the outfit consisting of a red shirt and jeans. Let's look at another example to make sure you've got it. Imagine you're at a restaurant. They offer a choice of main courses, represented by the set M, which contains pizza and burger. And they have a set of drinks, D, which includes Coke, Sprite, and water. To find all the possible meal combinations, we again use the Cartesian product, M cross D. This gives us pizza, Coke, pizza, Sprite, pizza, water, burger, Coke, burger, Sprite, and burger, water. So you can have pizza with Coke, pizza with Sprite, pizza with water, and so on. Each ordered pair represents a complete meal, a main course, and a drink. This concept will become even more useful as we move forward, especially when we start looking at scenarios with more than just two choices, as we'll see on the next slide. But for now, make sure you understand how the Cartesian product helps us systematically list out all possible combinations. More complex scenarios. So we've seen how Cartesian products help us find combinations with two sets, like shirts and pants, or meals and drinks. Now, let's push that idea a little further. This slide shows us that the concept isn't limited to just two sets. It actually extends to any number of sets. Think about it. In the previous examples, we were combining one item from one set with one item from another. What if we wanted to combine even more choices? Let's say you're planning a complete outfit. You need a shirt, pants, and shoes. To represent this mathematically, we can use a Cartesian product with three sets. Let's define those sets. We'll call the set of shirts SH, and it contains two shirts, shirt 1 and shirt 2. So SH equals the set containing shirt 1 and shirt 2. Next, we have the set of pants, which we'll call PA. This set contains pants 1 and pants 2. So PA equals the set containing pants 1 and pants 2. Finally, we have the set of shoes, SHO, with shoes 1 and shoes 2. Therefore, SHO equals the set containing shoes 1 and shoes 2. Now, to find all possible outfits, we need to find the Cartesian product of these three sets, SH cross PA cross SHO. What this means is we're creating ordered triples, combinations of one shirt, one pair of pants, and one pair of shoes. Voiceover. For example, one possible outfit would be shirt 1, pants 1, shoes 1. Another would be shirt 2, pants 2, shoes 2. This Cartesian product, SH cross PA cross SHO, will contain all such possible combinations. It's a systematic way to ensure we don't miss any outfit possibilities. Voiceover. This is a great stepping stone to understanding how Cartesian products can be used in more complex scenarios, and we'll see how the number of elements in the product grows as we add more sets, which we'll cover in the next slide. Key takeaways. Let's recap what we've learned about Cartesian products with these key takeaways. First, remember that Cartesian products give us all possible pairings when we take elements from two or more sets. Think back to the outfit example. We paired each shirt with each pair of pants to get every possible outfit. That's exactly what a Cartesian product does. It systematically creates all those combinations. Next, we saw how crucial Cartesian products are when we're dealing with coordinate systems, like the XY plane. The coordinate plane itself is a visual representation of a Cartesian product. If you have a set of possible X values and a set of possible Y values, the Cartesian product of those sets gives you all the possible points you can plot on that grid. So, understanding Cartesian products is fundamental to understanding how coordinates work. As we also explored with the outfits and meal examples, Cartesian products are incredibly useful for figuring out all the different combinations you can make. Anytime you're choosing items from different categories, like selecting a main course and a drink, you're essentially working with a Cartesian product. Finally, let's talk about the size of the Cartesian product. If you have two sets, let's say set A has m elements and set B has n elements, then the Cartesian product of A and B, written as across B, will have m times n elements. In other words, you multiply the number of elements in each set to find the total number of ordered pairs in the resulting Cartesian product. This is a really important point to remember when you're solving problems. Now, on the next slide, we'll look at some common mistakes students make with Cartesian products, so we can make sure you avoid those pitfalls. Common mistakes. First, a very frequent error students make is getting confused between A cross B and B cross A. Remember, we talked about how the Cartesian product gives us all possible ordered pairs. Well, that order is absolutely crucial. Because of this, A cross B is generally not the same as B cross A. Let's look at an example to make this crystal clear. Suppose we have a set A, which contains the numbers 1 and 2, and let's have a set B, which contains the letters A and B. If we calculate A cross B, which is the Cartesian product of A and B, we get the ordered pairs 1A, 1B, 2A, and 2B. Notice how the first element in each pair comes from set A, and the second comes from set B. Now, if we flip things around and calculate B cross A, we get a completely different set of ordered pairs, A1, A2, B1, and B2. Here, the first element comes from set B and the second from set A. As you can see, these are two distinct sets. They have different elements, even though they use the same original elements from A and B. So, always remember to pay attention to the order of the sets when calculating a Cartesian product. Finally, and this is really important, don't forget that the Cartesian product creates ordered pairs. This means that the order of the elements within each pair is significant. The pair 1A is not the same as the pair A1. It's a subtle point, but a very important one to remember when working with Cartesian products. So now we're moving on to a really important part of understanding Cartesian products, recognizing common mistakes. It's easy to slip up on a couple of things, and we want to make sure you've got a solid grasp of this before we move on. Understanding these potential pitfalls will really help you confidently apply Cartesian products to various real-world problems, like the ones we discussed earlier with outfits and meal combinations.